സേഫ്റ്റി വീക്കുമായിട്ട് ബന്ധപ്പെട്ടിട്ട് സാറിന്റെ സൗണ്ട് കേൾക്കുന്നില്ല കേട്ടോ. അനിൽകുമാർ സാർ സൗണ്ട് കേൾക്കുന്നില്ല.
ഹലോ ഹലോ.
ഓക്കെ 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 റൈറ്റ്. ഓക്കെ ഓക്കെ റൈറ്റ്.
തുടങ്ങാം നോക്കാം. ഹലോ ഹലോ.
യെസ്
തുടങ്ങാം.
ഹലോ.
Can we start?
ഹലോ
ഹലോ ഹലോ
ഹലോ പറയൂ പറയൂ. ഹലോ ഹലോ
ഹലോ ഹലോ.
വോയിസ് നോട്ട് ക്ലിയർ. ഹലോ
ഹലോ
ഹലോ.
കേൾക്കുന്നില്ലേ?
അനിൽകുമാർ സാറാണോ?
അതെ അതെ
അനിൽകുമാർ സാറാണോ?
അതെ
ഓക്കെ
അതെ.
ഓക്കെ 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 സാർ. ഓക്കെ 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 ഓക്കെ. കറക്റ്റ് 7 o'clock ആരെങ്കിലും വരാനുണ്ടെങ്കിൽ വന്നോട്ടെ. 7 o'clock we can start at 7 o'clock sir. Three more minutes we can start at 7 o'clock. Okay. 56. Okay. It's a part of National Electricity Safety Week. Okay. Yes, sir. Good evening. Good evening. Good evening, my dear safety professionals, and good evening to Sri Anil Kumar, sir, Chief Electrical Inspector, Government of Kerala, and Sri Gopakumar also. The National Safety Council has been conducting this National Electricity Safety Week from last year onwards. Last year it was only not this much program was not there. This time we are having 5 webinars of different subject on electrical safety. And today we are having on earthing and safety measures to be taken while earthing. And we anticipate more participants to join. And also the importance of today is Indian electricity rules came on this day in 1950s. So from last year onwards, Central Electricity Authority have initiated a move to have National Electricity Safety Week. So from 2020 onwards, we are observing 26th June to 2nd July as National Electricity Safety Week. This is a nationwide program. And to my knowledge, majority of the national safety chapters are not conducting. I think some of the chapter members have joined this program also. We are glad. Industry members as well as students, that is BTech and MTech students and research scholars doing research in safety are also attending this program. And we are blessed to have Shri VC Anil Kumar sir. He will be inaugurating the webinar series beginning today. Shri Anil Kumar, he was born in Ernakulam district and completed his B from MA College of Engineering, Kodamangalam. Started professional career as executive trainee in Travancore Cochin Chemicals. Subsequently joined in the Department of Electrical Inspectorate in 1990 and presently as the Chief Electrical Inspector, Government of Kerala. In a span of 30 years of service as occupied in the post of Secretary, Kerala State Electricity Licensing Board and Cinema Operator Examination Board. Also occupied the directorship of various government organizations and member of Standing Committee on Electrical Safety of Central Electricity Authority, Government of India. And I think to my knowledge, he is also there in the Safety Award Committee. He is also a member of the Safety Award Judging Committee since 2016 onwards. That is the factories and boiler. He is also there. So I invite you, sir, to inaugurate the session, the week-long webinar series in connection with the National Electricity Safety Week. I invite you, sir.
എല്ലാവർക്കും എൻ്റെ നമസ്കാരം.
Yes.
ജൂൺ 26 നമ്മുടെ ഒരു നാഷണൽ ഇലക്ട്രിക്കൽ സേഫ്റ്റി ഡേ. ഇത് കഴിഞ്ഞ് ഒരാഴ്ചത്തേക്ക് നാഷണൽ സേഫ്റ്റി വീക്കാണ്. നാഷണൽ സേഫ്റ്റി വീക്കിൻ്റെ ഉദ്ദേശം തന്നെ ജനങ്ങളുടെ ഇടയിൽ ഒരു സേഫ്റ്റിനെ കുറിച്ച് അവയർനെസ് ഉണ്ടാക്കുക, അവർക്കൊരു ഉത്സാഹം കൊടുക്കുക എന്നീ പൊതുജനങ്ങൾക്കിടെ അതിനു വേണ്ടിയാണ് ഒരു നാഷണൽ സേഫ്റ്റി വീക്ക് തന്നെ അതിൻ്റെ ഉദ്ദേശം തന്നെ. വൈദ്യുത സുരക്ഷ സംബന്ധിച്ച് ഇങ്ങനെയൊരു വെബിനാർ സംഘടിപ്പിച്ചതിൽ അതിയായ സന്തോഷമുണ്ട്. ഒരു മഹാമാരിയുടെ കാലഘട്ടത്തിലാണ് പോലും വളരെ പ്രതിബദ്ധതയോടുകൂടിയാണ് നാഷണൽ സേഫ്റ്റി കൗൺസിൽ കേരള ചാപ്റ്റർ ഇപ്രകാരം വെബിനാർ സംഘടിപ്പിച്ചത്. നാഷണൽ സേഫ്റ്റി കൗൺസിൽ കേരള ചാപ്റ്ററിൻ്റെ പ്രവൃത്തി ഇതിനൊരു ശ്ലാഘനീയമാണ്. നമുക്കറിയാം, നമ്മുടെ വൈദ്യുത ശൃംഖല മാറ്റങ്ങൾക്ക് വിധേയമായി കൊണ്ടിരിക്കുകയാണ്. ഈ മാറ്റങ്ങൾക്കനുസൃതമായി വൈദ്യുത സുരക്ഷയുടെ ആവശ്യകതയും വർദ്ധിച്ചു കൊണ്ടിരിക്കുകയാണ്. വൈദ്യുതാപകടങ്ങൾ ഒഴിവാക്കുന്നതിന് വേണ്ടി സർക്കാരും അതോറിറ്റിയും ബ്യൂറോ ഓഫ് ഇന്ത്യൻ സ്റ്റാൻഡേർഡും പല നടപടികളും എടുത്തിട്ടുണ്ട്. ഉദാഹരണം പറയുകയാണെങ്കിൽ നമുക്കറിയാം, ഇപ്പം പല മോട്ടോർ വെഹിക്കിളും ഇലക്ട്രിസിറ്റി ഉപയോഗിച്ചാണ് ഓടാൻ ധാരാളം റോഡിലിറങ്ങുന്നുണ്ട്. ഇവർക്കാവശ്യമായ ചാർജിങ് സ്റ്റേഷൻ, ഈ ചാർജിങ് സ്റ്റേഷൻ അതൊരു പുതിയതായിട്ട് നമ്മുടെ ഒരു ഇലക്ട്രിക്കലായിട്ട് വന്ന ഒരു ഉപകരണമാണ്. അതിനുവേണ്ടി തന്നെ അതിൻ്റെ സേഫ്റ്റി അതെങ്ങനെ ഉപയോഗിക്കും, സുരക്ഷിതമായി എങ്ങനെ ഉപയോഗിക്കുമെന്ന് വിചാരിച്ച് റെഗുലേഷനിൽ തന്നെ അതൊരു അമെൻമെൻറ്റ് സെൻട്രൽ സിറ്റി അതോറിറ്റി വരുത്തിയിട്ടുണ്ട്. അതുകൂടാതെ തന്നെ IS 3043, 732, NEC അമെൻമെൻറ്റ് പല പോലെ സ്റ്റാൻഡേർഡും റെഗുലേഷനും അത് അതിൻ്റെ റിവൈസ് വന്നേക്കണ കൂടുതൽ സുരക്ഷിത മാർഗങ്ങൾ ഉൾപ്പെടുത്തിക്കൊണ്ടാണ്. അതുപോലെ നമ്മുടെ സംസ്ഥാന സർക്കാരും ഈ സേഫ്റ്റിക്ക് വൈദ്യുത സുരക്ഷയ്ക്ക് ഊന്നൽ കൊടുത്തിരിക്കുകയാണ്. സംസ്ഥാന സർക്കാരിൻ്റെ ഒരു പോളിസിയാണ് സേഫ് പോളിസി. സേഫ് പദ്ധതിയിൽ ധാരാളം പ്രോഗ്രാമുകൾ നടത്തിയിട്ടുണ്ട്. കാരണം നമ്മൾ ലാസ്റ്റ് ടൈം തന്നെ അട്ടപ്പാടി ആ മേഖലയിലുള്ള ഒരു 600 വീടുകൾക്ക് ELCB വെച്ച് വയറിംഗ് നടത്തി കഴിഞ്ഞ വർഷം അതിൻ്റെ കംപ്ലീറ്റ് ചെയ്ത് ഫ്രീ ആയിട്ട് കൊടുത്തിട്ടുണ്ട്. ELCB 4 പോയിന്റ് വയറിംഗ് ഒക്കെ നടത്തി. അപ്പോൾ ഈ സേഫ് തന്നെ പല പ്രോഗ്രാമുകളും ഉണ്ട്. എന്നിരുന്നാലും കഴിഞ്ഞ വർഷങ്ങളിൽ വൈദ്യുത സംബന്ധമായ അപകടങ്ങളെ പരിമിതപ്പെടുത്തുവാൻ കഴിഞ്ഞിട്ടുണ്ടെങ്കിലും ഇനിയുള്ള മികവുള്ള പ്രവർത്തനം കാഴ്ചവെക്കേണ്ടത് അനിവാര്യമാണ്. കഴിഞ്ഞ വർഷം നമ്മൾ വൈദ്യുത അപകടങ്ങളുടെ കണക്ക് നോക്കുകയാണ്. കഴിഞ്ഞ വർഷം നമ്മുടെ കേരളത്തിൽ മൊത്തത്തിൽ 466 വൈദ്യുത അപകടങ്ങളുണ്ടായിരുന്നു. അതിലൊരു 52% ഏകദേശം 242 പേര് ജീവഹാനി സംഭവിച്ചു. ഒരു 35% 161 പേർക്ക് പരിക്ക് പറ്റി. 61 മൃഗങ്ങളും വൈദ്യുതാഘാതമേറ്റ് മരണപ്പെട്ടു. ഈ കണക്കെന്ന് പറഞ്ഞാൽ കഴിഞ്ഞ ഏപ്രിൽ തുടങ്ങി ഈ 21 മാർച്ച് വരെയുള്ള കണക്കാണ്. നമ്മൾ പ്രത്യേകിച്ച് ശ്രദ്ധിക്കേണ്ട ഈ അപകടങ്ങളിലെല്ലാം തന്നെ ഗാർഹിക മേഖലയുടെ അപകടങ്ങളാണ് വളരെ കൂടി വന്നിരിക്കുന്നത്. ഏകദേശം 186 അപകടങ്ങൾ ഗാർഹിക മേഖലയിലുണ്ടായിരുന്നു. അതിലേറെ 138 പേരാണ് മരണപ്പെട്ടത്. അതിൽ മാരകമായിട്ട് പല ഈ അപകടങ്ങൾ നമ്മൾ വിശകലനം ചെയ്യുമ്പോൾ ഇരുമ്പ് തോട്ടി കൊണ്ട് ഏണി എന്നുപയോഗിച്ച് വൈദ്യുത ലൈനിൽ സമീപം നമ്മൾ വൃക്ഷങ്ങളുടെ ഫലങ്ങൾ പറിക്കുമ്പോൾ ഉണ്ടാകുന്ന അപകടങ്ങളും ധാരാളമായിട്ട് ഈ കഴിഞ്ഞ വർഷം ഉണ്ടായിട്ടുണ്ട്. ഞാനിപ്പോൾ അതിൻ്റെ ഒരു ചെറിയൊരു കണക്കാണ് പറഞ്ഞത്. ഡീറ്റെയിൽഡ് കണക്കുണ്ട് എത്ര പേര് ലൈൻ പൊട്ടിയിട്ട് പിന്നെ ഓരോ ജില്ലയിൽ 4 ജില്ലയിലാണ് കൂടുതലായിട്ട് ആക്സിഡൻറ്റ് ഉണ്ടായിരിക്കുന്നത്. വിശകലനമുള്ള കണക്കുകളെല്ലാം തന്നെ ഡാറ്റ നമ്മുടെ കയ്യിലുണ്ട്. ഞാൻ കൂടുതൽ അത് വിശദീകരിക്കുന്നില്ല. ഒരു ഉദ്ഘാടനം എൻ്റെ പേരിൽ കൂടുതൽ ഡീറ്റെയിൽഡായിട്ട് പറയുന്നില്ല. ഈ ഞാനിപ്പോൾ മേൽക്കണക്കുകൾ സൂചിപ്പിക്കുന്ന വൈദ്യുത സുരക്ഷാ മേഖല ഒരുപാട് മെച്ചപ്പെടുത്തൽ നടത്തേണ്ടതിൻ്റെ ആവശ്യകതയാണ്. പ്രവൃത്തി മേഖലയിൽ ഒരു ജീവൻ പോലും നഷ്ടപ്പെടാതെ സുരക്ഷിതമായ വൈദ്യുത സപ്ലൈ സിസ്റ്റം നടപ്പിലാക്കുന്ന ശ്രമത്തിൽ നാം ഓരോരുത്തരും പങ്കാളിയാകേണ്ടതുണ്ട്. ആയതിലേക്കുള്ള ചുവടുവയ്പ്പായിരിക്കണം ഈ വെബിനാർ. നിങ്ങൾക്കെല്ലാവർക്കും ഉപകാരപ്രദമായ പഠന ശിബിരം ആശംസിച്ചുകൊണ്ട് ഈ വെബിനാർ ഉദ്ഘാടനം ചെയ്തതായി ഞാൻ പ്രഖ്യാപിക്കുന്നു. ഈ വെബിനാറിൽ പങ്കെടുത്ത് ക്ലാസ്സുകൾ എടുക്കാമെന്ന ശ്രീ എസ് ഗോപകുമാർ. ഇന്ന് ഗോപകുമാരൻ ക്ലാസ് എടുക്കുന്നത്. ഗോപകുമാരൻ ഞാൻ നല്ല അതിന് പറ്റിയൊരു ആപ്റ്റ് ഒരു പേഴ്സണാണ്. കാരണം പല മേഖലയിലും പുള്ളിയുടെ കഴിവ് തെളിയിച്ചിട്ടുള്ളതാണ്. ഞാൻ ബോംബെയിൽ ഒരു മീറ്റിങ്ങിന് പോയപ്പോഴും മിസ്റ്റർ ഗോപകുമാർ അവിടെ ഉണ്ടായിരുന്നു, പേപ്പർ പ്രസൻറ്റേഷൻ. അപ്പം ഇന്ന് പുള്ളിയുടെ വക ഒരു നല്ലൊരു പ്രസൻറ്റേഷനാണ് നമുക്ക് എല്ലാവർക്കും ഉള്ളത്. ബാക്കിയുള്ള ജെയിംസ് ഊട്ടി തോമസ്, പി അനിൽ കുമാർ, പി ഗോപാലക്ഷേമം എന്നിവർക്കും ഡിപ്പാർട്ട്മെൻറ്റിലെ പേര് എൻ്റെ സ്വന്തം നിലയിലും നന്ദി രേഖപ്പെടുത്താൻ കൂടി ഞാൻ ഈ അവസരം ഉപയോഗിക്കുകയാണ്. നമസ്കാരം. നന്ദി, നമസ്കാരം.
താങ്ക് യു സർ. താങ്ക് യു. നമ്മൾ അടുത്ത സെഷനിലേക്ക് നമ്മൾ പോകുകയാണ്. ദ നെക്സ്റ്റ് സെഷൻ ഈസ് ഓഫ് മിസ്റ്റർ ഗോപകുമാർ. ദ ഗോപകുമാർ ഈസ് giving the invited talk today on earth and electrical safety. He will be talking on that, earthing and electrical safety, by Shri Gopakumar. And Gopakumar is an eminent person, as Mr. Anil Kumar has rightly told. He was in the various committee of standardization of our BIS and IEC standards. Shri Gopakumar is an electrical engineer of Cape Electric. He is having more than 27 years of experience in electrical safety, lighting protection, and EMI and EMC of electrical installation. Conducted more than hundreds of site studies on failure in electronic equipment and presented papers in more than 1,000 seminars and training programs. He is a member in the working group of the following Indian and IEC technical committees and the technical coordinator for Lightning Awareness and Research Center at Trivandrum. He has published articles about safety in various magazines and published the book, The Missing Link in the Subject of Electrical Safety. Because this came to my mind whenever one accident or something happens, the immediate cause is the people used to tell us the culprit will be static electricity will be the first culprit. Then only the root cause, everything will come only the later stage. So at the first stage, everybody has got a tool. This is earthing fault or static electricity fault. Like that only it is coming. So I invite Sri Gopakumar to talk on the subject electrical safety and failure due to shortcuts. Welcome, Sri Gopakumar. Welcome.
Good evening, sir. ബഹുമാനപ്പെട്ട നമ്മുടെ കേരള സ്റ്റേറ്റ് ചീഫ് ഇലക്ട്രിക്കൽ ഇൻസ്പെക്ടർ അനിൽ കുമാർ സർ, നാഷണൽ സേഫ്റ്റി കൗൺസിൽ കേരള ചാപ്റ്ററിന്റെ സെക്രട്ടറി, എന്നാൽ നിങ്ങളുടെ പെർമിഷനോടുകൂടി ഞാൻ എൻ്റെ പ്രസന്റേഷൻ സ്റ്റാർട്ട് ചെയ്യുന്നു. ഇന്നത്തെ ഇതെൻ്റെ നാലാമത്തെ പ്രസന്റേഷൻ ആണ്. ഈ സേഫ്റ്റി വീക്ക് സ്റ്റാർട്ട് ചെയ്തതിന് ശേഷം ഇനി അടുത്ത ഒരാഴ്ച ടോട്ടലി ഒരു 25-26ഓളം പ്രസന്റേഷൻ ആണ് എനിക്ക് ചെയ്യാനുള്ളത്, ഓരോ ദിവസവും 3-4 വെച്ച്. However, with your permission, I start the presentation. My presentation is about, I hope my sound is clear and you are able to see the presentation properly.
Yes, sir. Clear. Okay. Presentation is visible.
Thank you. So,
okay, proceed.
Yeah, our subject is earthing and electrical safety. As all of you know, that earthing is a very critical part in electrical safety. It is like in a building you are making a foundation. If the foundation is strong, building will last long. The same way, if the earthing is strong, your electrical installation will last long without any trouble, without any fault, or with minimum fault, and it will give you a very good reliable electrical installation. So with respect to our standard, we have National Electrical Code 2011, the new regulation, the new National Electrical Code is under preparation. Most probably within 6 months. I was told that within 3 months, probably the National Electrical Code will be coming, probably, but I think about 6 months it will come. Then the IS 732, which is called as Code of Practice of Electrical Wiring. Actually, this IS 732 is borrowed or adopted from IEC 60364, which is the parent document for worldwide low voltage electrical safety. Why I mean, or what I mean worldwide electrical safety is, be it America or Europe or Singapore or Malaysia or Japan or South Korea or any other developed country, the same electrical safety methods or the systems are used. For example, in America, the National Electrical Code, NEC, or it is also called as NFPA 70, it follows IEC 60364. In British BS 7671, that also follows IEC 60364. Germany VD 100 also follows the same IEC standard. France and all European nations, they follow the same system. And we also have the equivalent standard, which is called as IS 732. So more than the National Electrical Code, I would say IS 732 is with respect to electrical installation inside a building, IS 732 is more important. So protection is ensured by protection, in an electrical installation. There are different kind of protections required. One is the first one and the most important one is protection against electric shock. Then protection against thermal effect, protection against overcurrent and short circuit. The fourth one is protection against overvoltage. These are the 4 fundamental safety requirements in an electrical installation. So I would start with the protection against fire, which is one of the biggest threat which we are facing every day. Fire due to electricity or fire ignited from electricity. And the related issues. You are very much aware of the problems which electricity is creating, especially with respect to fire. Fire, generally, our assumption, I am talking from the IEC standard 60961, part 1. the subpart 10 has got several subdivisions, 10, 11, 12, 13, 14, like that. Several subdivisions are there. This series of standards explains how to handle fire in an electrical apparatus or in an electrotechnical product. That means whatever the appliance or apparatus which we are using finally, how the electrical, the fire situation is handled in that particular equipment. So generally fire, the reasons are short circuit, accidental sparks or arcs, high transient peak current and abnormal temperature rise. These are the four identified reasons for ignition of fire from electricity. The equipment, sometime you must be aware that all the latest fire accidents in hospitals were because of the fire from air conditioners. Even last week, there was a fire accident in AIMS, Delhi, where the refrigerator caught fire, but luckily nothing happened. The equipment are getting fire or because of the insulation failure, because of a short circuit or because of a fault, earth fault, the equipment are getting damaged. As a result, it starts a fire. Now, imagine an air conditioner which is faulty. This air conditioner, if it is designed and tested and conforming to the highest standard, you can be sure that this air conditioner is not capable of creating a fire. It is not capable of igniting a fire because the device itself shall satisfy certain its own safety requirement. But the problem is, imagine the air conditioner is faulty. And still you keep on supplying the power supply, keep on supplying the power to the air conditioner, then it becomes fire. So it is not the equipment which is creating fire, it is the power supply which is actually the problem. If the power supply is disconnected, your problem is gone. A fault becomes fire because there are 2 points here. One is the time and the next one is the energy. Both the time and energy, depending upon both the parameters, heat is generated in the equipment due to arcing or due to resistive heating. As a result, your equipment start igniting, and if the ignition you are able to stop within certain time. To stop the ignition, you should understand that the supply is more important. What kind of supply you have connected your equipment. Now here, the power supply categorization, power supply in the sense finally the circuit which is feeding power to an electrical apparatus, it is categorized into 3 classes, class 1, 2 and 3. In class 1 you are seeing a green color, it means if you look at the time 0, 1, 2, 3 and here on the y-axis you can see the power of the fault. If the power in the fault is limited to less than, here there is a limit, less than 15 watts within 3 seconds. Within 3 seconds, the power of the fault is limited to less than 15 watts. In that particular case, electricity or that particular equipment is not having enough power to ignite fire. So this device cannot ignite fire. If the power is limited to something about 100 watts within 5 seconds, here 5 seconds, 100 watts, less than 100 watts within 5 seconds, still the equipment is unable to ignite fire provided there is it's a free area, and if the environment contains some ignitable materials, it could ignite a fire. So ignition under some conditions is possible under the power supply class 2. Power supply class 3, which exceeds the limit of power supply class 2, here the cause of ignition is very much possible. I'm just showing you a video from the one of the COVID hospital. You can also see this video in the YouTube. There is an apparatus. The nurses, they identified some problem. They are running. They are trying to remove the patient. Now you look at inside the circle. Inside there is a spark. There is a flash. Then again, the power supply to that particular equipment is on. As a result, you know what is going on. Slowly the smoke comes. Then there is a larger explosion. And within 3 minutes, this room is full of smoke. And you must understand you must think about the situation. There are patients, those who are sometimes unconscious, those who are connected with a lot of medical equipment. So they have to be evacuated, which is very risky. In the same situation, you please think that the fire started from this particular equipment. I show it again. The fire started from the equipment. Now their doctors or the people, those who are nearby, they identified a problem. If the power supply is disconnected within 3 seconds, of course, there is no fire. So this is the point. The power supply shall be disconnected within the limited time. Time is very important. Your apparatus as well as the electrical installation, if the installation is following all the safety rules of the standard, they are able to withstand up to 3 seconds, but the disconnection shall happen much before that. Now, the power supply categorization, we can interpret into different ways. Anyway, I don't want to go into that. We actually carried out a survey in several hospitals during this COVID time. And what we found is in most of the hospitals, especially in the final circuit, there is no protective conductor. Protective conductor means earth wire. From the MCB DB to the socket, there is no earth wire, only phase and neutral goes. Some cases, the earth wire is damaged. In some cases, earth wire is undersized. If we take 100 cases, almost 90 cases are the earth wires are in problem. Only in 10% of the cases, the earth wire is properly installed and tested. So this is not a good situation. In such kind of an installation, if there is an earth fault, you can be sure that some accident is going to happen. With respect to RCDs, only limited places RCDs are installed. Large hospitals with own transformers, because the hospitals we electrically categorized. There are small hospitals with one LT supply, medium level hospitals with multiple LT supplies, and large hospitals with a high voltage supply. In large hospitals, the biggest problem which we could see is TT system is used instead of TNS system, and there is no earth fault protection, which is a serious matter for a discussion. The point number 6, 7, and 8. These are actually the basic testing required in an electrical installation once when you complete the electrical wiring. The first one, continuity test to find out loose contacts. 100% not carried out because they are not aware. Fault loop impedance and efficiency of automatic disconnection of supply. 100% not carried out. Method to reduce insulation degradation, 100% not carried out. And these are some of the findings which we found. So basically the safety culture itself is missing, and the awareness about the standards and its requirements are, I would say, there is a wide gap. A lot of places, these hospitals, they carried out thermography. Because thermography, doctors feel that, there is a nice camera. I can see my panel board in yellow, white, green, and red color. Take a picture. Then, you make a picture, and whenever there is a problem, you can look into the picture and get satisfied. Actually, thermography cannot improve to your expected level. Thermography is not included in the standard, low voltage standard, as a reliable testing method other than solar PV. In solar PV, yes. Other than solar PV, thermography is not a recognized way of testing, because you must understand that in a low voltage electrical installation, the protective conductor, we generally call as earth wire. The protective conductor is the most important wire who has to be in a very strong condition to ensure safety. And this protective conductor is always off. It is in off condition. So thermography cannot find out the reliability of protective conductor, which is a very big drawback. So don't imagine that by making a thermography, you ensure the entire safety and you can be sure that safety is achieved, which is unfortunately not possible. What is the test? Then what is the alternate? The first test recommended in IS 732 is to find out the loose contacts and weak points in a wiring, especially in the final circuit. Here, the test is called as continuity resistance of the wiring. What is continuity resistance of the wiring? From the MCB DB to the socket, after pulling the wire through the conduit, you are supposed to, let us say you have a single phase wiring. In that case, you have 3 wires, the phase conductor, neutral, and earth conductor. Up to 16 square mm, the sizing of all the 3 conductors shall be same. So the resistance of the wire shall be measured with a very good quality, if possible, a micro ohm meter. then you should compare the value with the reference. So as a result, you are able to find out whether any loose contacts and cuts and joints are there or not. Now, this particular test, every year you cannot do. One electrical installation, after pulling the wire, after connecting your sockets, you should do once. And next you can do it probably after 25-30 years. You cannot do this test every time. Now, in case due to running, if the wiring has become weak, what do? There is the test number 2, fault loop impedance. The impedance of the circuit is measured and the protective efficiency of the protective device is ensured by doing this particular test. In case of loose contacts, then this test, which is an online test, you need to have the power supply. If you do this particular test periodically, for example, every 1 year or 2 year, you will be very much, you will be able to find out the fault in your system. So this is how actually you should do, or this is what actually you must do. But unfortunately, in the hospitals, the situation is not very good. Not only in the hospitals, most of the electrical installation. I would say that electrical engineers, those who are participating in this webinar, you please ask your colleagues, those who are doing probably design or contracting, you ask them how many circuits are you testing fault loop impedance and continuity resistance. Then you will be able to understand the seriousness of the situation. We are supposed to test it every circuit. And this is not a new standard. It is existing since 1989. So as I said, the problem is the safety system which we are following is not exactly what is recommended. What is fault loop impedance? I am showing you a typical electrical installation or electrical system, an electrical system consisting of a source, load or an installation, and the distribution. The consisting of source, distribution, and an electrical installation. I am showing you a system earthing called as TNS. TNS stands for the exposed conductive parts of the installation are connected to the means of earthing. That means the transformer neutral through a separate protective conductor. Separate protective conductor is called as TNS. This is how a single line diagram of a TNS system looks like, the primary requirement. In case of any fault in this particular installation, the fault current from the fault, it goes back to the source through the protective conductor. It goes through the winding of the source. It returns back to the fault, and the impedance of this wiring, this complete wiring, including the protective conductor impedance, the winding impedance of the transformer, and the impedance from the transformer up to the source. This parameter actually decides the amount of fault current. Very simple. ZS shall be lesser than U0 divided by IA. U0 is the nominal voltage, line to neutral voltage or line to earth voltage. Let us say 230 volt. IA is the fault current. So the fault loop impedance calculations are included in the standard. Now, basically, the impedance of this network decide the amount of the fault current, and that amount of fault current decide the disconnection time. IS 732 says the fault loop impedance shall be 2/3 of the tested value. Let us say in a network you have the fault loop impedance of 100 milliohm, but you should consider only 2/3 of the value. Now, in the new National Electrical Code, we have included this particular chart. This particular chart, let us say, this is ZS in ohm, depending upon the rating of the MCB, type C MCB, ZS. Let us say a 32 amps MCB, the fault loop impedance is 0.48 ohm. In case of a 63 amps MCB, 0.24 ohm. This chart or this table is included. As a result, it makes very easy. For simple understanding, resistance of the wire influence the disconnection time. Testing fault loop impedance is of high importance because it ensures you that in case of any problem, your device is able to disconnect. Now imagine you have a hospital starting with a transformer, you have the main distribution board, you have the sub distribution board, and you have the final MCB DB, and you have the devices here, MCBs. And at the output, your air conditioner started burning. and your wiring and equipment are able to withstand up to 3 seconds. And in case of a fault of negligible impedance, this particular MCB, which is feeding the power to the air conditioner, is supposed to disconnect within 200 milliseconds. We have a safety margin of almost 15 times, provided the MCB is tripping within 200 milliseconds. If the MCB is not tripping 200 milliseconds, and if it is passing more than 300 milliseconds, then we go to a dangerous situation. Our average testing in most of the electrical installation shows that, let us say in a typical case, final circuit is a 20 amps type C MCB, line to neutral fault 190 amps to 260 amps. That means a type C MCB of 20 amps require 200 amps, 10 times its rated current to disconnect within 200 milliseconds. Line to neutral fault, it is able to disconnect within the safe time, whereas in the earth fault, the fault current is only 10 amps to 60 amps. Because this whole network is like a TT, the transformer neutral is separately earthed, the main distribution board is separately earthed. Of course, under the soil there is a connection, but the length of this loop is so large, the resistance is very high. As a result, the current is much lower. What will happen in this case? The air conditioner will keep on burning if there is an earth fault, and finally it becomes fire. There is short circuit protection, but there is no earth fault protection. Now, what is the solution for this case? The simple solution is you use instead of MCB, you use RCBO. But remember, RCBO or the RCD, residual current device, is supposed to be an additional protective device. By providing an RCBO, you can increase the safety in this particular case. The second way, but it's the first one is an expensive method. The second one is convert your network from TT to TNS or TNCS. By simple method, this change is possible. In one of the hospital, just with 5,000-6,000 rupees, this solution is made, and after making the solution converting from TT to TNCS, then we tested the fault currents was much higher, about 300-320 amps. As a result, we are sure that the MCBs are able to trip. So the first and the most important safety parameter, I would like to tell you that in case of any problem, within certain time, your protective device should disconnect. Your protective device should trip. Another point, generally what people say in hospital, earlier the hospital, the number of electrical items were less, but during COVID, a lot of people are there. So as a result, a lot of equipment are connected and the complete wiring is overloaded. As a result of overloading, fire happened. Actually, you should understand that overloading cannot ignite a fire if the MCBs and the protective devices are properly working. You have an MCB 20 amps and your wiring is able to withstand 20 amps. If the current is more than 20 amps, instead of fire, your MCB is supposed to trip. Why the MCB is not tripping? Because most of us, we don't test it. That is the problem. Electrical system basically is divided into two, earthed system and unearthed system with respect to safety. In an earthed system, safety is achieved by automatic disconnection of supply. The safety measure is called as protective equipotential bonding and automatic disconnection of supply. Especially the fault protection is achieved by protective equipotential bonding and automatic disconnection of supply. Whereas in an unearthed system, fault protection is achieved by protective equipotential bonding and monitoring of insulation. Insulation monitoring devices are used in unearthed system. Unearthed system, you don't need to disconnect the supply, and this is used in special cases like operation theaters in hospitals, telecom centers, computer data centers, instrumentation system, and lighting in inaccessible area. In those places, you can use an unearthed system. So basically, there are two kind of power supplies which we can use in our electrical system. The first one, earthed, means in case of any trouble, the MCB should trip. The second one, unearthed, in case of any fault, first fault, your system need not have to trip. The power supply to the equipment can continue because you are monitoring the insulation. There is no safety hazard in that particular system. The system earthing. Remember, system earthing in the heading, what you are seeing is system earthing. System consists of a source, distribution, and installation. Sometimes we use the name earthing system. The meaning of earthing system is the arrangements made in a consumer premise in order to achieve earthing. So system earthing and earthing system are two different names. Now, earthing system has been removed from the standards. The new word is earthing arrangement. The new term which has to be used is earthing arrangement. Here, system earthing. System earthing means you have a power supply system, and how are you going to earth the power supply system, which consists of a source, a distribution, and an electrical installation. There are different system earthing called as TNC, TNS, TNCS, TT, and there is one more which is called as IT, unearthed system. But the earthed systems are shown here: TNC, TNS, TNCS, and TT. So the first point of earthing is to identify the location in a building where you need to have disconnection as a safety measure and no disconnection as a safety measure. Then if you go for a disconnection as per an earthed system, then you should understand, or you should implement one of the safety measure. You can go for TNC, TNS, TNCS, or TT, but TNC is not recommended for today's electronic appliance. You can go for the other three. And if we look at what our regulation and the standard says, the CEA regulation and the IS standards mostly recommend TNS or TNCS. But what we do practically is something like a TT. Say, for example, the transformer neutral is connected to earth pit 2 numbers, and the body of the equipment are connected to other electrically independent 2 numbers of earth pit. This is what is carried out across most of the states in India. But of course, Kerala is an exception in comparison to other states. So here, the important point which the consumer should ensure is protective equipotential bonding and automatic disconnection of supply. How the consumer can ensure automatic disconnection of supply? Say, for example, here in this, I am talking about a TNS system from the electricity distribution company. You have a TNS system, and here the place where I am moving the cursor is the origin of installation. That means the meter board. So actually the impedance of the system is decided by the supplier's transformer and the line length plus the size of the lines. In European countries, if you get a power supply from the utility company, it is the responsibility of the utility company to tell the client that, look, at the origin of installation, fault loop impedance is, let us say, 300 milliohm. The expected fault current is this much. This parameter is a mandatory parameter with which the supplier is supposed to give. Number two, the supplier is supposed to provide a protective device at the meter board. That particular protective device is rated based on the fault loop impedance. That means the supplier, the electrician or the lineman, he has to have a fault loop impedance meter. Before giving the supply, he has to measure the fault loop impedance and he has to give the fuse according to that particular value. But unfortunately, this is quite new in the country. None of the utility companies are following it. Probably in the future, you can see these requirements, because in the new CEA regulation, the upcoming CEA regulation, this is included. Whenever we talk about earthing, the biggest issue which comes is people start asking 2 for neutral, 2 for body. I am buying a DG, where to connect 2 earth pit, how to make 2 earth pit. Shall I go for chemical earth, digital earth, pipe in pipe earth, and what kind of compound which I should put? All these questions come into picture. But unfortunately, the separate earth electrode is an idea which is too old. It won't help you. So it is not at all recommended in any of the standard, but we follow it because we misinterpret these standards. Similarly, the second part, clean earthing, like all the electronic appliances. Let us say in a hospital, all the biomedical equipments are sometimes separately earthed or sometimes connected together and to an earth electrode in soil. Power equipment are connected to a separate earth electrode. Lightning protection is connected to a separate earth electrode. This is also unfortunately a wrong method. In some cases, there are 3 earth electrodes, but all the 3 are interconnected together. Because if we tell that you must have only one earthing, then people, engineers will come out, yeah, I have interconnected everything under the soil. As a result, I have only one earth. This is also wrong. This kind of a connection will increase the length of the conductor. As a result, the impedances are higher. Once when the impedances are higher, you have to be sure that the fault current is lesser and disconnection time is more. So this is also not the recommended method. The recommended method is called as a multiple bonded earth electrode. What does it mean is the exposed and extraneous conductive parts in an installation are interconnected at various levels or various points. Here, let us say under the soil, maybe at the first floor, maybe at the second floor. These one are horizontally also connected. So basically you get a very good earthing system or earthing network by making this kind of a connection. Of course, your UPS also can be connected, your electronic appliance can be connected, your inverter air conditioner can be connected, your inverter can be connected, your biomedical equipment also can be connected to this particular network. But before connecting each and every equipment, you should understand what is the requirement of functional earthing for electronic equipment. So there is a subject called functional earthing. So depending upon the functional earthing, we should decide what exactly need to do. But otherwise, in principle, everything is interconnected together at various locations. That is the correct way of earthing. One misinterpreted subject in our region, especially in India and some of the neighboring countries, are we call grounding and earthing. We always have a doubt what is grounding and what is earthing. Some people say grounding is used for neutral of a power source and earthing is used for body of an equipment. This is the general misinterpretation. Actually, it's wrong. Earthing is used in the IEC standards, the European standards, and finally this is the IEC standard, and finally that is the standard which is followed in India, whereas the wording grounding is used in all the American standards like the NFPA, NEC of America, the IEEE standards, UL standards. So whatever the documents coming from America, you can see the wording grounding. Otherwise, for a transformer neutral or for the complete power supply system, in IEC it's system earthing and in America it's system grounding. Earth electrode in India, ground electrode in America. Earth electrode network in India, ground electrode network in America. So basically the interpretation, we must use the word earthing rather than grounding, because if we use grounding, people always try to think that grounding is related to transformer neutral. So please don't use that particular name. Similarly, the last one, ground fault, earth fault and ground fault. Earth fault is used in India, ground fault is used in America. Earthing shall be made based on your equipment. Number one, what is the demand of the equipment? Electronic equipment often will have a symbol like this, 5018. This is called as clean earthing. The latest word is, this is called as functional earthing. Functional earthing means an electronic apparatus, in order to work properly, it requires a reference plane, a reference. Basically, this is applicable for communicating equipment. The equipment, if two equipment are communicating each other, functional earthing is quite important, digital communication. 5019 is called as safety earthing. 5017 is just an earthing. It can be either 5018 or 19, not specifically mentioned. The symbol 5017 not specifically mentioned. 5018 is a typical application of a functional earthing system. 5019 is a typical application for a safety earthing system. 5020 is called as chassis earthing. Chassis earthing means this is the earthing which is the reference point for a large electrical installation. You can see this particular picture in IS 3043. DG and changeover system, how to make the earthing. I think the picture number is 38 onwards. There are 4 or 5 pictures. What I am explaining is only the earthing part. I am not talking about how the changeover is happening. Now you should see that the engine and the alternator body is connected to a bus bar. Exposed conductive part is connected to a bus bar. The incoming EB supply TNCS is shown is also connected to the same bus bar, which is nothing but the main MET, main earthing terminal of your building. The outgoing circuits earthing is also connected to the MET. Neutral of the DG is also connected to the MET. The MET is also connected to extraneous conductive part, means all the metallic pipes, structural steel, lightning down conductor and metallic pipes, and all these things are connected to the MET. And finally, this MET is connected to an independent earth electrode. Look at the symbol 5020. It's a chassis earth. That means you are supposed to create a reference for this complete electrical installation. So earthing shall be made based on the symbol which is required for a particular application. The word earthing doesn't mean earth electrode. Earth electrode is only one of the item in the earthing system. This complete earthing system, say for example, the wire which is used, the connection, the joint which is made, and all these things are called as earthing. Now, how to make an earthing in the electrical installation? What I mean is a consumer premise. If you have an industry and if you have a lot of electrical apparatus, how to make the earthing? You have, for example, sub panel and motor body. I just put it as an example. These are called as exposed conductive parts. You have the MET or the main earth terminal, which is also called as equipotential bonding terminal. You have the constructional steel down conductors of lightning protection system. You have metal pipe, and these are called as extraneous conductive part. You have an earth electrode in soil, provided it's a TT system, and you have the transformer neutral, provided it is a TN system. Now, interconnecting MET with the exposed conductive part is called as protective earthing, and these conductors, these wires are called as protective earthing conductor. That means from the main distribution board, the earthing wires which is going towards your load side is called as protective earthing conductor. From the main earth bus bar, the wires used to connect all the metallic items in your building is called as protective bonding conductor. From the MET towards the earth electrode in case of a TT or towards the neutral in case of a TN, these are called as earthing conductor. Please understand, these wordings are very clever to understand and it's very difficult to remember. Protective earthing, protective bonding, earthing conductor, supplementary protective bonding conductor, that means additional connections within a large installation, and all these conductors together are called as protective conductors. So when it comes to earthing, if you actually wanted to look into the earthing, these the meanings, the method of selection, and the required resistances of all these wires you should understand, and you should make your design accordingly. Normally, the MCB rating and the wire size. I have seen in some places people select the MCBs based on the wire size, or wires are selected based on the MCB size. Actually, this is not correct. The wires in a conduit is selected based on several parameters, such as the resistance of the copper wire, number of wires through the conduit, length of the wire, and there are several influencing factors. If the length of the wire is more, heat is more. If more number of wires are inside a conduit, heat is more. Once when the heat is more, inversely the resistance is inversely proportional. As a result, resistance increases. Once when the resistance increases, further heat comes. So the most important point in a wiring is the resistance of the wire which is installed inside a conduit. There are two kind of flexible wires available in the market, which is called as, the first one is called as a class 2 copper wire. That means a flexible wire where the resistance of the wire, the copper, is lesser. It is about 7 to 8%. Class 2 conductor is having a resistance 7 to 8% lesser in comparison to class 5 copper conductor. I would say class 5 copper conductor, the application is this class 5 has to be used in a panel board wiring. You cannot put those wire through a conduit. You are doing wrong, because all the conduit calculation, the heat dissipation calculation are based on the class 2 copper wire. The continuity resistance testing shall be made based on class 2 wire. But unfortunately, we always use class 5 copper wire in our wiring. The result is 6%, 7 to 8% higher temperature in the class 2 conductor. This high 7 to 8% higher resistance increases the heat dissipation through the conduit, higher heat in the pipe, increased impedance, reduced fault current, and finally your MCB will not trip, or the MCB will take more time to trip. If the MCB is taking more time to trip, of course you are compromising the safety. So I would say the class 2 wires must not be used in house wiring. However, in the new National Electrical Code, we have written it, and there is one more document which is going to come up, a guide for implementing electrical standards in an electrical installation. In that particular document also, we have very clearly written the wires which is used in a house wiring or in an industrial building wiring must be of class 2 copper. You are not supposed to use class 5 copper. Of course, if I tell this to a wire supplier, they will shoot me down, but unfortunately, I have no other way. One of the fire accident creator is inverter. Inverters are creating not only fire, it also creates a lot of shock hazard. Inverter with the single pole disconnection is what is used in nowadays in our country, because inverter with the 2-pole disconnection is mostly not available nowadays. What is recommended in the standard is, here there is an inverter. You please look at where I am moving the cursor, the line and neutral, bypass line and neutral, both there is 2-pole isolation. Line and neutral are isolated. Whereas what we do in our inverters, only the line is isolated. Sometime the inverter will create a backfeed in the sense the neutral of the inverter is actually the phase. As a result, power will backfeed, and there are incidents where a person who works on the HT line even get a shock from the inverter. So inverters are one of the risky items. I would say if you wanted to have a very good electrical installation, you should ban the usage of inverter with single pole isolation, because in the standard, this picture and the installation very clearly written, you must use an inverter with the 2-pole isolation. Of course, if you ban within a short time, manufacturers will come out with a solution. The manufacturers won't be in a problem for a longer time. It's a temporary situation. If you tell that within 6 months, all inverters, after 6 months, all the inverters sold in Kerala must have 2-pole isolation, then people will follow. One of the problem which we are facing is engineers don't give importance or attention to national regulation. We have very good regulation, very good electrical safety standards, but we don't give a proper importance to it. As a result, what we do, for example, lightning protection, these photographs, what you are seeing is called as non-standard lightning protection system. The first two are called as a lightning eliminator. That means it will eliminate lightning. The cloud itself will disappear. The next four are called as early streamer emission lightning LPS, early streamer emission lightning air terminal. So basically what these people say is it will attract lightning from a faraway distance. So if you put this in your building, not only you, all your neighbors will be protected. So if you have good neighbors, you can have this kind of a device and you can protect all your neighbors. Whereas the first one, these are called as lightning eliminators. This item was introduced in about 30 years back. Initially, they told it will dissipate lightning. Then the story is changed a few occasions, and the latest story of this particular item is they say, if you install this particular item, lightning will not hit your building. Instead, it will go to your neighbor's building. So if you have neighbors with a lot of problem, you can install this kind of a rod. All lightning will go to your neighbor. Basically, these stories are really not at all accepted in any of the standard. Of course, ESC is accepted in a French standard, but there is a big history behind that. I don't want to explain that. So basically, lightning protection is an amazing story for all of us. We are fascinated with the story. We don't look into whether the storyteller tells the truth or not. As a result, we are always carried away by the fascinating stories of the lightning protection system. On the right hand side, what you are seeing is a wooden pole and a cycle rim. Just for a joke, we call this a cycle rim lightning protection. The inventor of this lightning protection system says this is a beautiful modern lightning protection system. A few pieces, maybe 3 to 5 pieces, can protect the entire village. 5 years back, the story started with 3-4 pieces will protect the entire village. But now slowly they are changing the story. But basically, these are not only non-standard system, these are actually dangerous system. You can see here under a tree, this system is installed. In a school, this is installed. This is a college somewhere in West Bengal. These are installed. So basically, LPS, lightning protection system, is a fascinating story. People always go with the under the fascinating story, and they don't follow the national standard. As a result, what happens is all non-standard items are installed in your building, and finally what you get is no protection. So this we call this as a cycle rim lightning protection. This is again a big, this was one of the biggest scam in lightning protection going on in India. Across India, 37,000 installations are made in some Jharkhand or some state. And here I am showing you an installation from Odisha. Normal RCC building, lightning protection, cyclone shelter. In this cyclone shelter, on the left side, you are seeing the drawing. One moment, please. You are seeing the design of this lightning protection system. There is a building, and here where I am moving the cursor, some isolated FRP poles, and at the top of the pole, some air terminals, some metallic terminals are used. The idea is this complete building has been installed with an isolated lightning protection system. Isolated lightning protection system means the lightning, here you see this particular conductor. You can see a conductor where I have shown on the second right side picture. There is a pipe, and inside the pipe an insulated wire is running. This insulated wire is called as a separate, a very expensive isolated conductor. Now, this complete electrical installation, this complete lightning protection system has been made similar to a lightning protection system implemented in a explosive storage area. Like, if you store gelatin sticks, or if you store some explosive, you need to, if you store missiles, for example, in a defense installation, you need to have a sophisticated electric lightning protection system. So this kind of a normal cyclone shelter is installed with this fascinating lightning protection system. But what happens within 6 months, you can see here on the center picture, the conductors are hanging. So basically, lightning protection is an area which you must be very careful while selecting, because more than what is required, stories are running around. Regarding the earthing with respect to the safety regulation, the regulation 14 of the Central Electricity Regulatory Authority safety regulation says the supplier shall provide a suitable switchgear, earthed and earthed neutral conductor. Often the meaning of this earthed and earthed neutral conductor is misinterpreted. So I would like to explain you what is the meaning of earthed conductor. Earthed conductor means you have a transformer, you have the consumer installation, here the source, distribution, and the origin of installation. Origin of installation is nothing but the meter board. You have the blue color, a phase conductor from the transformer. You have the black color, the neutral conductor from the transformer. You have the protective earth conductor from the transformer. The meaning of the earth conductor is this is a TNS system. You are supposed to get an earth conductor from the supplier, which is mentioned in the regulation 15. In the regulation, it is written as earth conductor, or earthed conductor, but we must understand that earthed conductor was a very old definition. The new definition is earthing conductor. Similarly, the conductor, the second one, earthed neutral conductor, is equal to a PEN conductor in a TNCS system. What does it mean? 4 wires. In the previous one, the first one, it's a 5-wire distribution system. 3-phase neutral and earth conductor is coming from the transformer to every consumer premise. The second one is a 4-wire earthing system or 4-wire distribution system. 3-phase and neutral plus PE, and the 4th wire is called as PEN conductor. It's a combined conductor. 4 wires comes at the meter board. The supplier shall take a link. He will provide an earth terminal. He will provide a neutral terminal, and he make a link. And this is actually written in the regulation. If the voltage is more than 250 volt, the consumer is supposed to have one more earth electrode. Regulation 16. Regulation 15 talks about earthed conductor. And the regulation 41.1 talks about the earthing of the neutral conductor. And regulation 15 also talks about the indication of the earth terminal. Regulation 15 also talk about no cutout, no switch or linked switch shall be there on the earthed conductor or earthed neutral conductor. All these things are very beautifully explained in the standard. But unfortunately, what we do or what is carried out in most of the state utilities are not exactly like this. TNS, of course, nowhere it is followed, or probably only 2 to 3% of the installations are TNS, very rarely used. TNCS, of course, some of the places it's used, but what is missing is this particular link. The neutral and earth link at the incoming distribution board or at the meter board is missing. As a result, what happens is your network becomes TT. Instead of TNCS, which is recommended in the standard, your network becomes TT. And if you have a TT network, the meter board must have a 30 milliampere RCD for earth fault protection or leakage protection. So this is the way the regulations shall be read. For example, regulation 14.1, switchgear on consumer premise by supplier. That means before the terminal or at the meter board, the consumer, the supplier shall provide a switchgear. Similarly, 14.2 talks about switchgear by the consumer. After the terminal, the consumer can have his own switchgear. All these things are very well documented in the regulation. Similarly, IS 732 explains how to make your meter board in case of a public distribution system. These pictures are there. The picture is figure 61, IS 732. But unfortunately, what happens is these are not followed very well. So sometimes people don't, the utilities didn't understand the meaning of it. These are actually highly important. If the installations are made according to the rules and regulations, in case of any problem in the consumer premise, the incoming fuse will disconnect. In addition, I would say the fault loop impedance at the origin of installation. Here, this is the origin of installation at this place, the fault loop impedance. It is the responsibility of the electrical supply company or the Discom to measure the fault loop impedance of the incoming supply and to decide the rating of this particular switchgear. In the new or the upcoming regulation, these are written in a better way. So I would say the things are slowly going to change. Similarly, regulation 40, earlier it was talking about test for resistance of insulation. At the top, I am showing you the old regulation. The red one was the existing one. The green is the changed one. In the new regulation, it is test of installation. Installation means a consumer premise. Whenever from the main distribution board up to the last place, or an installation in the sense, if you are a HT supplier, from the transformer up to the last socket, you are supposed to make the testing, and the testing shall be done as per IS 732 part number 6. Regulation number 41, connection with the earth. Most important regulation, which is called as how to make earthing in an installation. Now, the part number 1 and part number 2, it is replaced with the neutral conductor of a 3-phase 4-wire system and middle conductor of a 2-phase 3-wire system shall be earthed as per IS 3043. With one line, it has been replaced. As a result, the system is much more clear. The confusions are gone. Now some more clarifications had come. The red color regulations are already changed. Now here, point number 10, no person shall make a connection with the earth by the aid nor what is explained in the standard is you are supposed to make a protective equipotential bonding. That means all the pipes, metal frame and all shall be connected to the MET, but in a very in a language which is very difficult to understand. Now it has been removed or changed as every building shall have protective equipotential bonding by interconnecting exposed and extraneous conductive parts as per IS 3043 and IS 732. Very simple. Like this, the regulation already changed. I show you one more change. Say, for example, earlier it was written as this point number B. Earlier it was limit the earth resistance. That means you have an earth pit, earth electrode, limit the earth resistance sufficiently low to permit adequate fault current for the operation of protective device in the time to reduce neutral shifting. Now it is changed to maintain earth fault loop impedance sufficiently low to permit adequate fault current for operation of protective device within the permitted time stipulated in IS 3043. So basically, The earth pit story is gone. Now fault loop impedance comes into picture. Again, fault loop impedances are explained in the same regulation 41, sub-regulations 16, 17, 18 and so on. Say for example, the last one, 20, where multiple sources are used in the same installation, example transformer and DG with changeover facility, fault loop impedance shall be tested for both the sources and automatic disconnection of supply shall be ensured for both the supply sources. So a lot of changes are going to come. You have to be very careful. Now, with respect to the regulation number 7172, what is recommended is this kind of a system, which is called as a TNCS system. You can also read the explanations in IS 3043 clause number 4. Statutory requirement of earthing. What does it say is the source is earthed. The neutral conductor, the PEN conductor is earthed to the earth electrode at every third pole or every 5 times or 3 times in the distribution. At the consumer premise, you also shall have earthing. And whenever there is a crossing, you have to have the guard wires and so on. All these things are very clearly explained in the regulation, but unfortunately, we don't read it very properly. Now, one subject, I have only 2 slides. I will close it as fast as possible. One subject which we are supposed to seriously think is the temporary overvoltage in a consumer premise. Imagine you have your house. At some occasion, the transformer HT side, high voltage side of the transformer is having a fault. There is an earth fault at the high voltage side, something like this. So here you have a transformer, you have your installation, there is a fault at the high voltage side. What will happen is electrical apparatus in your equipment or electrical apparatus in your house go bad. It will burn because of a temporary overvoltage. Instead of 230 volt between line and neutral, or instead of let us say 400 volt between phase to phase, sometimes the voltages are in an erratic way between between the line and the body U2. Between the line and body, sometime a voltage of up to 400-500 volt can come, which will destroy your equipment. Now, it is the responsibility of the electricity supplier to ensure that such temporary overvoltages are limited. In other way, I would say, due to a high voltage fault, if your equipment gone bad, the electricity supply company is supposed to compensate you because they didn't do their job properly. They didn't do their earthing properly. As a result, your equipment are burning. There is a chance that the person inside your building also get a shock. So IS 732 very clearly explains what the supplier should do in order to limit the temporary overvoltages in your building as well as the shock voltages in your building, depending upon the kind of network, TT or TN system, whether the source earthing, HT and LT earthings are connected together or separated, and these things are there. I have an animated video. If you are interested, probably next time I can show it. Finally, inspection, testing and certification, or testing, inspection and certification. An electrical installation consists of a design, selection and erection, finally testing and inspection. The first part is inspection. Inspection consists of 19 parts. 19 different inspection points are there. Let us look at point number 2, presence of fire barriers. What does it mean? In multi-storied buildings, once on the electrical shaft or once when the power wires or power cables transfer from or get transferred from one zone to the other zone, we are supposed to install fire barriers. As a result of the fire barriers, fire and smoke is not transferred from one area to the other area. So it has to be checked. That means what kind of materials are used, are they tested, test certificates are available and so on. This itself is a big job. Other precaution against propagation of fire. There are some more methods of containing or stopping the fire propagation. Those are installed or not. And the final one, protection against thermal effect. What is thermal effect? It means in case of an overcurrent or an fault, excess temperatures are not created in your electrical installation. The inspection number 2 itself contains lot of job. It is not like you read 19 points and from one side of the building you start doing it and by evening you can finish it. No, it is not possible. So these are recommended in the standard since several years. After inspection, we are supposed to do the testing of an electrical installation. There are 10 different testings. As I said, in the new regulation 40 has very clearly written the new and revamped electrical installation. You should do the testing as per IS 732. Not only testing, verification means inspection and testing as per IS 732. Testing consists of 10 different testings. Out of the first 4 testings are in off condition, and the next 6 testings are in on condition. Be sure that the earth electrode or the earth pit resistance measurement is not at all necessary. It has been already removed. So the test starting with continuity of conductor, I would say resistance of the conductor. Test number 6, automatic disconnection of supply, which consists of fault loop impedance measurement, line to line, line to neutral, and line to earth impedance shall be measured. The fault or the short circuit current shall be established, and the disconnection time shall be verified. So these are the testings which is included in the new standard. In the upcoming NEC, these are a very big stress has been given. The regulation, very big stress is given. As a result, I would say within a year, by the end of this year, or probably when we speak about the next year electrical safety week, the situation of electrical safety in India will change. We are working for it. Now, what is important is there is a big knowledge gap. So in order to reduce that, I hope most of you must be aware of CISA. CISA is an NGO based out of Trivandrum. Under CISA, under Electrical Inspectorate in association with CISA, or CISA in association with Electrical Inspectorate, during 2004, 2005, up to 2014-15, we conducted a lot of awareness classes on lightning safety. We did lot of awareness classes on lightning safety. Now we took up the next job, Vidyut Surakshit Bharat Abhiyan. This is a campaign, 1-year-long campaign across India to increase the knowledge of people. We have selected a few subjects. The 7 subjects are given here. Basic design criteria of LV installation, basic network, system earthing. The second one is all about earthing. Third one is about inspection and testing. Fourth one is electrical safety in hospitals. Fifth one is training of trainers, because a lot of people take classes on safety. So we train them. They can attend our training program free of charge and learn what exactly they should educate others. Sixth one, understanding of the standards and regulations. Seventh one, solar PV installation. So we are arranging these trainings on these subjects, and the trainings are on free of cost. Out of these, the third one, testing. The fifth one is also talking about testing. Testing is not an online class. All the other classes are online, but testing is our engineers or volunteers will come to the site and they will do the testing. We have made a temporary website as well, vidyutsuraksha.com. You can log into the website and you can register. People can register, engineers can register, volunteers can register, and organizations also can register. Organizations like railway, several organizations registered. So by this, I would like to stop the presentation. Thank you very much. You can note down my email address and telephone number. You can also get the book missing link, which we published last year, but unfortunately we printed 10,000 copies. Only 1,000 is left out. Balance are over. So by this, I would like to stop my presentation. Over to you, sir. Hello, can you hear me?
Yeah, thank you, sir.
Hello. Yeah, 1 minute, Manaf. 1 minute. Yeah, Mr. Gopakumarji, you had made a very good presentation, which enabled non-electrical engineer also to understand something about electrical. You spoke about IS standard 732 and also confusing words of used on earthing and grounding. That also you explained well. And also Vidyut, also you will be taking the next session, I think on 2nd July, because our National Electrical Safety Week starts with Gopakumar, and he is also concluding the section on 2nd July 2021. Now I invite our friends to ask any questions, if any they can ask right now. And Jacob also, there are some question has come in the chat box also. Mr. Jacob, please check it up. Mr. Jacob.
Okay, sir. The participants can unmute themselves now to ask questions.
Okay,
I'm giving the permission for them.
Some questions are already there, Jacob.
Okay, okay.
Hello?
Any questions?
Hello?
Hello, you're audible.
Jacob.
Sir.
Yes, you are audible.
Hello? Can you hear me? Hello?
Yes, we can hear you. Please continue.
Okay, I'm sorry. Assistant Electrical Inspector in Department of Kerala. Electrical Inspectorate. Hello?
Good afternoon, Mr. Salim. Sorry, good
okay.
evening, Mr. Salim. Yeah.
Okay, okay. Firstly, I would like to congratulate you for being the inaugural presenter
Thank you very much.
for the National Electrical Safety Week. I have some points to note. Okay, can you hear me?
Please continue.
ഈ ലൂപ്പ് ഇംപെഡൻസും പിന്നെ അതുപോലെ പിന്നെ ലൂപ്പ് ഇംപെഡൻസിന്റെ പിന്നെ അതിനെക്കുറിച്ചുള്ള ഒരു അവയർനെസ് ഈ ഇലക്ട്രിക്കൽ കോൺട്രാക്ടേഴ്സിലും. ഹലോ, കേൾക്കുന്നുണ്ടോ?
കേൾക്കുന്നു.
ലൂപ്പ് ഇംപെഡൻസിന്റെ പ്രാധാന്യത്തെക്കുറിച്ച് ഒരു അവയർനെസ് മിക്കവർക്കും ഇല്ല. അത് ഉണ്ടാക്കാനായിട്ട് എന്ത് ചെയ്യാൻ പറ്റും എന്നുള്ളതൊന്ന് ആലോചിക്കണം. അതാണ് മിക്ക നമ്മുടെ ഇൻസ്റ്റലേഷൻ്റെയും ഒരു പ്രശ്നങ്ങൾ. ഹലോ,
ഓക്കെ. ഇതിന് നമ്മുടെ ഇപ്പോൾ കേരള സ്റ്റേറ്റ് ഇലക്ട്രിക്കൽ കോൺട്രാക്ടേഴ്സ് അസോസിയേഷൻ, ഐ തിങ്ക് എ ഗ്രേഡ് കോൺട്രാക്ടേഴ്സ് അസോസിയേഷൻ, അവർ നമ്മുടെ ഈ പ്രോഗ്രാമിന് ഓൾറെഡി ഇത് വിദ്യുത് സുരക്ഷ ഭാരത് അഭിയാൻ, they have already registered in the program. So we will take a lot of classes. Now, see, if we wanted to, I would request the host to unmute other people. Otherwise, it was creating a little bit of trouble.
Yes, sir. I have
My dear friends, those who are not talking, please unmute.
So here actually for educating to the mass, we have to travel across Kerala. We have to go to every village headquarter, every district headquarter, and we have to have demonstrations. We are planning it probably once when the situation is improving. You know, now at the moment we cannot send our engineers because it's the situation is not so good. Once when the system, once when the things improve, we will send our engineers to district headquarters. But for demonstrating this testing, we need to have a live installation. We can do it in a building. So if you can arrange some building with the electricity supply working condition, we can demonstrate this testing. And in last 3 years, for example, I think 2 years or 2.5 years back, there was some program organized by the Electrical Inspectorate Ernakulam and Electrical Inspectorate, I think Alapi. In Ernakulam, I remember I was carrying this particular meter and we showed it in the distribution board. But we can, you know, one explanation probably is not enough. We can do it repeatedly and we can achieve.
I have some more questions. Please. Hello.
Please.
System earthing and equipment earthing. ഇതിനെക്കുറിച്ചുള്ള തറവാട്ടുള്ള ഒരു ഡിഫറൻസിയേഷൻ ഇൻ ബിറ്റ്വീൻ സിസ്റ്റം ആൻഡ് എക്വിപ്മെന്റ് എർത്തിങ്. ഹലോ.
Actually, if we, for example, the TTTN IT system, understanding these different earthing system will take at least 2-3 hours because we have to start from the basic onwards. We were continuously doing this kind of classes. Last year also, system earthing and equipment earthing, we did almost 25 classes and lot of hundreds of people participated. Or I would say thousands of people participated. We have the videos uploaded in the YouTube and other media. Those also can be referred, but we can also make special classes for the people in Kerala. Anyway, thank you very much, Anil Kumar sir. He has approved our program, the Vidyut Surakshit Bharat Abhiyan campaign, and we will make exclusive classes for the engineers in Kerala. We can do a lot of classes and we can educate each one of them.
Also, differentiation between earthing and earthing arrangements.
Earthing is a general term.
Earthing and earthing arrangements, differentiation between.
Yeah, imagine you have a bus bar.
These two.
Yes, imagine you have a bus bar. You have a panel board. You take a wire and the panel board earth bus bar is connected to the main earthing bus bar incoming earth bus bar coming along with the cable. That particular connection is earthing. Earthing arrangement means the connection, the wire, the bus bar all together are called as earthing arrangement.
Okay, thank you. Then another one. Why TNC system is not recommended?
TNC, the neutral and the earth conductors are combined. So there is no earth conductor separately. This is not suitable for present day electronics. So it will create a problem. Probably in the detailed classes I will explain this part.
Okay.
Sir, there are two questions which have arrived actually.
So I could see one of the questions, why single point isolation in a high-rise building having isolation only faces, not neutral?
Yeah.
Okay, if, the isolation of faces will do the job. Because this is basically for achieving safety. In case of any trouble inside the building, power supply should not continue for a longer time. This is an emergency. This is for the emergency purpose, especially fire safety or whatever. So you can isolate the power supply, the faces. As a result, the power supply to the entire building is stopped. That's very simple. So,
sir, another question is that can I connect KCB neutral to earth in my meter board?
Technically speaking, KCB is supposed to do that. In the meter board, you will have, if you have a three-phase supply, 4 wires are coming. The phase neutral, combined neutral conductors, 4 wires are coming, 3-phase and the combined conductor. KCB meter board will have 5 terminals, 3-phase terminal, 1 neutral terminal and 1 earth terminal. The link between neutral terminal and earth terminal shall be made by KCB. You cannot do it. And inside the building, please never connect the neutral conductor to other parts like exposed extraneous, but don't earth neutral at the inside the house. That is wrong.
Sir, there's another question. What is AFDD? How it can prevent fire?
Okay, one moment. Somebody just told that my telephone number has got 5 numbers. People to
yeah, sir, 11 numbers.
Sorry.
11 numbers. Okay.
That 5 was extra.
Right. Okay, now it is correct. Okay.
So the other question, what was the question, sir?
What is AFDD? How can it prevent fire?
Yeah, AFDD stands for arc flash detection device. Arc flash or arcing, whenever there is a loose contact in your wiring or whenever a phase wire is a little bit disconnected, arcings may occur. So AFDD is a device which monitors the arcing in your network, especially in between lines or between line and neutral. It is not between line and earth. So between lines and neutral, whenever there is a loose contact, there is a chance of arcing, and this particular device will disconnect the supply in case of any arcing. Generally, it is recommended for in bedrooms, for example, in residences, in bedrooms, these are recommended because the wire sometime is running through some route, and probably if some rat or something cut the wire, this device will disconnect. So AFDD is used for in case of any arcing, it will disconnect. So now in modern building, you will have the MCB, you will have the RCCB, and then you will have the AFDD. Now there are components, there are devices available which is a combination of all the three. Thank you, sir. The next question, I hope it is answered.
Hello, one more question, please. Hello.
Yes.
Inspectorate ഇപ്പോൾ മെയിനായിട്ടും ചെയ്യുന്ന ഒരു ടെസ്റ്റാണ് ഈ സോയിൽ റെസിസ്റ്റീവ് ടെസ്റ്റ്, ഒരു എർത്ത് റെസിസ്റ്റൻസ് ടെസ്റ്റ്. അതാണ് അവോയ്ഡിങ് എർത്ത് റെസിസ്റ്റൻസ് എന്ന് പറഞ്ഞൊരു ഒരു ഓപ്ഷൻ നമ്മുടെ ഇതിൽ ഡിസ്കഷനിൽ പറഞ്ഞിരുന്നു. എന്തിനാണ് എർത്ത് റെസിസ്റ്റൻസ് അവോയ്ഡ് ചെയ്യേണ്ട ആവശ്യകത വരുന്നത്? ആ ടെസ്റ്റിന്റെ ആവശ്യകത ഇല്ലേ?
അതെ, ലോ വോൾട്ടേജ് ഇലക്ട്രിക്കൽ ഇൻസ്റ്റലേഷൻ, ലോ വോൾട്ടേജ്
ലോ വോൾട്ടേജ് അല്ല ഹൈ വോൾട്ടേജ്.
Let me complete, sir. Up to a transformer, let us say you have a 11 kV transformer or a 22 kV transformer or up to 33 kV. Your starting is let us say 33 kV. Then downstream you have the transformer, main distribution, probably DGs, and finally up to the socket. In that particular case, we are supposed to make a TNS system, which is which is written everywhere. Now, if you go for a TNS system, you are not supposed to, or you are not depending on the earth electrode resistance on the LT side. Now, 33 kV side, there is a problem. 33 kV side, if you go for a TT system in the 33 kV side, of course, this measurement is required. But if you have a larger installation and if you have a TNS system with at the downstream, most of the time your electrode resistance requirements are fulfilled.
Okay. Thank you.
The next question is that if we have PLC and transformer in same building, does earthing can be made of same earth pit?
Of course, yes. Not on the same earth pit, on the same bus bar. The same bus bar in the sense, let me go back to the slide. I'm sure you are able to see the slides. I will show it on the slide so that it is easy for you to. Imagine this is your building, and so this one is the main earth bus bar. If you have electronics, you have to have a functional earthing conductor. Functional earthing means this is your PLC. Probably it is one PLC or a group of PLCs, but basically everything shall be interconnected. That means in the PLC which I have written, there are several electronic items. First, depending upon the type of the electronic item which you are using, depending upon its configuration and frequency, you should make a network, a localized network. So localized network, there are several topologies allowed, like star topology, ring topology, mesh topology, and so on. First, you make that particular topology, and finally, from that topology, you take a single point, an insulated conductor, and connect it to the MET, and this is called as a single point grounding. So you don't need to connect it to the earth pit, and this is the correct way of earthing. But what we do is individual equipment connect to earth pit. What we can do is in the future programs which we are doing, you must understand that explaining all these subjects in 2 hours presentation or 1 hour presentation is very difficult. In future classes, we will try to explain this subject as well so that you will be able to do. So before making this connection, you should do some small homework. You should find out what is the requirement of earthing in your equipment, like this, what kind of symbols are there in your equipment, and this functional earthing is required only if you have this kind of an equipment. Then you should do functional earthing. We can educate you, not an issue. Thank you very much.
So the next question is, if a power tool like grinding machine has removed the original connection and kept only phases and no earthing cable, what happens to the machine? If a power tool like grinding machine has removed the original connection and kept only phases and no earthing cable, what happens to the machine? If the same tool connected to a multi-socket, will it be tripped off at IP PDBs?
Yeah. 2 points you must consider. The condition number 1 is there is no residual current device. There is no ELCB. Simple word ELCB or RCCB, let us say. If you have an ELCB or RCCB 30 milliampere, then the condition is 1. If there is no ELCB or RCCB, then the condition is 2. Now here the rating of the ELCB which I am saying is maximum 30 milliampere. If your power supply is coming through a properly rated or less than 30 milliampere RCCB, your RCCB will trip. As a result, nothing will happen to you during an insulation failure in your grinder. Number 2, there is no RCCB. Your grinder is faulty. That means the body of the grinder is now 230 volt. And if you go and touch it, you will have the worst effect. If the current through your body is more than the limit, then electrocution will happen, and the results are you are aware. So you will get hit. So I hope I answered it.
Okay, sir. Next question is running earth wire from TR to consumer premises. Is it followed anywhere in Kerala?
Actually, this is if I answer, this becomes a little bit political. So it is not carried out, to be frank. How I know is 2 years back there was some case going on in the High Court, and there was an affidavit filed by the KCB. There they have replied that the earthing conductor is not, the safety measures are not made. Say for example, one of the regulation, I think regulation 100 or 102 or 103, I don't remember the number exactly. They say the transformer at the outgoing of the transformer shall have a properly rated switch gears, protective devices like MCB or MCCB. But most of the time we see only the old porcelain the fuses, and instead of fuse wires, you know how fuse wires are used. The same line conductor, the aluminum thick wire, is used as a fuse wire. As a result, the purpose of safety is beaten up. Number 2, the protective conductor as a TNCS or a TNS system, I think most of the places is not carried out. Especially I know in my house, in Parasala, it is all TT. So over to you, sir. Any question? Next question.
What control? Okay.
Yeah. Proceed.
What control measure we can adopt in households to avoid excess voltage hazard due to earth fault from supplier side?
You cannot do anything. This has to be done by the supplier. Okay. By deciding whether the HT and LT is together or separate, and by controlling the resistance of that combined or separate earth resistance. So basically, this is the job of the supplier. But if you have a proper TNS system, then you can do something in your installation. That means if you have your own transformer, and at the low voltage side, LT side, if you are going for a TNS system, then it is very much under your control. You can limit all these problems.
Okay.
Over to you, sir.
The next question is that, can we earth our neutral coming with main supply in our premise?
I think I already replied it. This has to be done by the electricity company and not by you.
Okay. The next question is, if MCB SC rating B, C or D to be selected as per fault loop impedance, how to address the starting current requirements based on application like lightning, UPS, etc.?
Yes, it's very simple. The first parameter to be selected, the MCB shall be selected based on your load current and the type of load. Let us say a typical load, you require type C MCB 20 amps. So the fault loop, the 20 amps MCB disconnection time in 200 milliseconds, example 10 times rated current, 200 amps is the required fault current, and the respective fault loop impedance is something about let us say 0.4, 0.9 or 0.8 ohm. Instead of type C, if you use a type D MCB, the fault current required for the same disconnection time is 20 times. That means in the type C 20 amps MCB, 200 amps current is required. Type D, 20 amps MCB, 400 amps current is required. 20 times 400 amps MCB require a fault loop impedance half of what is required for a type C MCB. That means the network, the impedance of the network, the incoming supply shall be much more lower. That is why, depending upon your MCB rating, you should do the selection.
Okay, sir.
So I have seen the next question. In case of solar PV installation in industrial area, is it recommended to connect earthing to the existing earth pit or make a separate earth pit and interconnect to make? In case of solar PV installation in industrial area, if it is a rooftop or if it is the grid connected system, rooftop system, the frame shall be interconnected properly. 3 wires comes from the solar PV up to the inverter DC side. The positive, the negative, and the earth wire. Earth wire is nothing but all the body are interconnected together. It comes up to the inverter. Then at the inverter manufacturer decides whether it is a DC earthed system or DC negative earthed or positive earthed system. That is up to the inverter supplier. And that particular, the third wire, earth wire coming, it has to continue up to the incoming power supply, and it has to be connected to the main earth bus bar of the incoming power supply. You don't need to connect it at the earth electrode as the primary requirement. So the primary requirement is the continuity up to the incoming supply shall be ensured. Additionally, you can have any number of earth electrode. That is a different case. But if you go for a rooftop installation, let us say a multi-storied building, 5 floors building, running 2-3 runs of strips from the 5th floor up to the earth pit, that is not going to help you. Instead, you must make a very strong connection from the frame of the solar PV panels up to the incoming protective conductor or the earth wire. So also please understand this question, if I answer so straight, one question will lead to the next question, which will lead to the third question, fourth question. It's like a chain reaction. So if I answer one, the next question will come. Probably we either we need a lot of time to clarify, or probably we can clarify all these questions in the next upcoming programs.
Okay, sir. Okay, sir. I now invite Sri Manaf Abdullah, Assistant General Manager Safety of Cochin Shipyard, to give an vote of thanks.
Thank you, Ramesh ji. Am I audible? Am I audible?
Yes.
Okay. Thank you, Ramesh ji.
You are audible. Yeah, audible. Proceed.
Let me come to the concluding segment of this fruitful session. I deem it a great honor to thank Sri VC Anil Kumar sir, Chief Electrical Inspector, Government of Kerala, who took out some time from his busy schedule to inaugurate the webinar series on electrical safety. Thank you, sir, for your insightful speech, especially on accident statistics and the need for safety in power distribution system. It's a privilege and honor for me to thank one of the pioneers of electrical safety, Sri S. Gopakumar, who took out his valuable time to throw light on the key aspects of electrical safety. I, on behalf of National Safety Council, truly appreciate you, sir, for the wonderful and insightful session on electrical safety, especially the earthing systems. I am sure all of us had many crucial takeaways from this affluent stretch on one of the vital topics in electrical safety. Your session was very focused, gave us a transparent and deep understanding on the key areas of earthing and electrical safety. Thank you, sir. I would also like to thank Dr. V.M. Ramesh, Secretary, National Safety Council, for his vision, foresight, and commitment for crafting such a useful session to the safety professionals of Kerala. My heartfelt thanks to each and every key personnel of National Safety Council who took the initiative and effort for a smooth ride of this webinar. Thank you all. Last but not the least, A special note of appreciation to all the distinguished attendees. A session becomes productive when we have a great participative audience. Thank you all for being a wonderful audience. Thank you all. Jai Hind.
Thank you. Thank you. Thank you, Manaf. Thank you.
So
Thanks
thanks
a lot.
very much, sir. Thank you. Thanks for all.
Thank you. Thank
See
you. Thank you.
next week.
Thank
See
you.
you next week.
Thank you, sir. Thank you. Manaf, thank you.
Thank you, sir. Thank you, sir.
Thank you. Thank you. Thank you. Okay.